Hi, this is Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical. Today, I am going to discussing about electrochemical series. Now, what is an electrochemical series and what is the important applications of electrochemical series we are going to discuss. Okay, first coming to the definition, how we can define electrochemical series. So it is nothing but series of different electrodes which are arranged in their increasing or decreasing order of their standard direction potential values. So, arrangement of electrodes with their either increasing or decreasing of standard direction potential values, that is known as electrochemical series. So, here what is the direction potential? We have discussed in previous classes. So, potential is nothing but tendency to either gain or lose of electron. If it is gains, that is known as reduction potential. Or if it is loses, tendency to loses, that is known as oxidation potential. Why? Because we know that what is a reduction and what is an oxidation. So oxidation is nothing but addition of oxygen or removal of electrons. Whereas reduction is the nothing but gain of electrons or removal of oxygen. So that is known as reduction and oxidation. Now, it is a tendency to gain of electrons, that is known as reduction potentials. So depends on reduction potential values, we are going to arrange electrodes in a series, that is known as electrochemical series. So let us see what is the electrochemical series. Look at this one. So this is the arrangement of different electrodes. You can take this one and this one, both are same series. Suppose if you take this one, here we have arranged different electrodes with their standard direction potential values. So different electrodes along with their standard direction potential values we have arranged. So what we can understand by seeing this series. So here from this series we can say that reduction potential values of electrodes decreases from top to bottom. So reducing nature will be decreases from top to bottom in this series. And one more thing also we can understand, that is oxidation nature. So oxidation nature increases from bottom to top of in this series. So in this series different electrodes are arranged with their decreasing order of standard direction potential values on hydrogen scale. Why? Because here hydrogen electrode is reference electrodes. The potential of hydrogen electrode is 0. That's why we have choose hydrogen electrode as a reference electrode to determine the nature of other electrodes. So on the basis of hydrogen electrode, we can explain the nature of different electrodes. So from the series, we can understand some electrodes are arranged on above the hydrogen and some electrodes are arranged in below the hydrogen. So reducing power decreases from top to bottom of this series, as well as oxidation nature increases from bottom to above of this series. Okay, so from this series we can decide that which electrode act as a anode and which electrode act as a cathode. Also we can predict with the help of electrochemical series. So the negative sign of standard direction potential. So when you observe, some standard potential values contains negative sign, and some potential values has positive values. So this negative sign before the potential value indicates that when your electrode which has negative potential value, when that is connected with the reference electrode, that should be act as a anode. So negative sign indicates potential, those potential value has negative, that particular electrode when connected with the reference electrode act as a anode, whereas electrode with the positive potential value, when it is connected with electrode, that should be act as a cathode. So oxidation takes place at anode and reduction takes place at cathode. So the strong reducing agents, then hydrogen, are placed above the hydrogen in the series, have negative values of standard reduction potential values. So as we know, reducing nature decreases the EL to EL. So strong reducing agents, these are act as a strong reducing agents which are arranged above the hydrogen electrode. So when comparing lithium and potassium, lithium is a strong reducing agent. Why? Because reducing nature decreases from top to bottom in electrochemical series. Similarly, those electrodes act as a strong oxidizing agents that should be arranged in below the hydrogen. So these electrodes act as oxidizing agents, strong oxidizing agents. Okay, so that is the about electrochemical series. So electrochemical series is nothing but arrangement of different electrodes with their increasing or decreasing order of standard direction potential values. That is electrochemical series. So coming to the principle, coming to the applications. What are the applications of electrochemical series? So first application of electrochemical series is prediction of anode and cathode. So usually we don't know which electrode act as a anode and which electrode act as a cathode. So from electrochemical series we can predict the nature of electrode, which one act as a anode and which one act as a cathode. We can predict from the electrochemical series. Now let us see how we can decide which one act as a anode and which one act as cathode. So those electrode which contains high potential value, that is a high standard direction potential values, that should be cathode. For example, if you take copper and zinc. Okay, so among these two electrodes, copper has plus 0.34 potential values and zinc has minus 0.76. So standard direction potential of copper is very high when comparing with the zinc. So that's why copper acts as a cathode and zinc acts as a anode. So similarly, the nature of various electrodes also we can find with the help of electrochemical series. Only if you know the value of standard reduction potential value, then we can find which one act as a anode and which one act as a cathode. So those electrode which has high standard reduction potential value, that should be act as a cathode, and those electrode which has less standard reduction potential value, that should be anode. So oxidation takes place at anode and reduction takes place at cathode. So that is the first application of electrochemical series, prediction of anode and cathode. Next, coming to the second application, calculation of standard EMF. So we know that what is the EMF? EMF is electromotive force, a force which causes flow of electrons in between the electrodes in an electrochemical cell, that is known as EMF. So we can calculate EMF by using these three types of formulas, that is E0 cell is equal to E0 RHE, right hand electrode, minus E0 LHE, left hand electrode, or E0 cell is equal to E0 reduction minus oxidation. E0 is equal to E0 of reduction potential minus E0 of oxidation potential. And third one is E0 cell is equal to E0 of standard cathode and E0 of anode. That means standard reduction potential at cathode minus standard reduction potential at anode. From electrochemical series, already we have find out. We can find which one act as a cathode and which one act as a anode. So standard reduction potential of cathode minus standard reduction potential of anode. Then we can find EMF. So that is a calculation of EMF or determination of EMF of a cell we can find with the help of electrochemical series. And next, coming to the third one, displacement of one element by the other, or displacement of one electrode by other in a chemical reactions. So usually as we know, displacement chemical reactions, how displacement of one electrode by another electrode, that nature of displacement of electrons also we can study with the help of electrochemical series. So electrode which has less standard reduction potential value will displace those electrode having greater standard reduction potential value. So electrode with less potential value can displace the electrode with high standard reduction potential value. So if you take again copper and zinc, so among these two electrodes, zinc has less standard reduction potential value, that is minus 0.76. So zinc will displace by copper from the solution. For example, if you take Zn plus CuSO4, in this reaction, zinc has less standard potential value than copper, that is plus 0.34. So simply Zn can replace the copper present in the solution as a Cu plus 2 and forms ZnSO4. So this is the best example for displacement reaction. So in this reaction, zinc can replace the copper from copper sulfate solution and forms ZnSO4. This is because zinc has less standard potential value than copper. That's why zinc simply can replace the copper present in the copper sulfate and forms ZnSO4. Okay, so that is the displacement of one electrode by other, or displacement of one element by other element in a chemical reactions. And next coming to the fourth one, relative ease of oxidation and reduction. That means which electrode will undergoes oxidation and which electrode will undergoes reduction. Also we can predict with the help of electrochemical series. Suppose if you take fluorine and lithium from electrochemical series, fluorine has standard reduction potential of plus 2.87. Lithium has negative potential value of minus 3.04. So higher the value of standard reduction potential, greater is tendency to get reduced. So among these, lithium has high tendency towards reduction and fluorine has high tendency towards oxidation. So electrode with high standard reduction potential value, that is highest negative standard reduction potential value, that has tendency towards reduction. Whereas electrode with high positive potential value, that is very familiar towards oxidation. So that is the relative ease of oxidation and reduction reactions. Next coming to the predicting feasibility of the reaction. Feasibility of a reaction. So feasibility is nothing but spontaneous. 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 So what is a spontaneous? It is a independent of the reaction. So it does not depend on other parameters. Reaction should be very feasible. So feasibility of the reaction also we can determine with the help of electrochemical series. So the feasibility of redox reaction can be predicted by help of electrochemical series. So E naught cell is equal to E naught cathode minus E naught anode. So that is a standard reduction potential of cell is equal to standard reduction potential at cathode minus standard reduction oxidation potential at anode. So to predict the feasibility of the cell reaction, first we have to know what is the relationship between the free energy, that is free energy change, that is delta G is equal to minus NF E. So delta G is nothing but free energy change in a reaction. N is the number of electrons involved in the reaction. F is the constant Faraday and E is the electron. Okay. So if the delta in general E naught of the cell is positive, the reaction is feasible. If E naught cell is the negative, then that reaction is not feasible. So if you take the following reaction, that is silver plus Zn. Silver plus Zn. Is it feasible or not? Let us consider example for to check the feasibility of the reaction, that is silver plus Zn plus 2 gives rise to silver plus Zn. So let us check. At anode, as we know, oxidation takes place. So the standard potential value at the anode is 0.80. At cathode, reduction takes place, as we know. So standard reduction potential at cathode is minus 0.763. So by taking the formula, E naught cell is equal to E naught cathode minus E naught anode, then minus 0.763 minus 0.80. So E naught cell is equal to minus 1.563 volts. Since E naught cell is the negative, so that given reaction is not visible. So in this way, we can find any type of reaction if you know the potential value of anodes and cathodes. So if you know the potential value of anode and cathode, simply you can find which reaction is feasible and which reaction is not feasible. So that is the electrochemical series. So electrochemical series is nothing but arrangement of different electrodes with their standard potential values either increasing or decreasing. So from the electrochemical series, we can find out prediction of anode and cathode, and we can calculate standard EMF of the cell and displacement of one electrode by another electrode, and relative ease of oxidation and reduction, and final and last one is prediction of feasibility of the cell reaction. So that is about electrochemical series and their applications. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.